All right, welcome back. We're going to spend our day or our activity drawing our first iterations of cosine and sine. How exciting. Using theta or the angle as the input and the output being the x or y coordinate for the corresponding point on the unit circle. Hence why I was so annoying or such a nuisance about that when we first started our unit circle explorations. Although I've got it when I can use the coordinates of points on the unit circle to graph the cosine and sine functions. So it's going to be really important that we also remember or are able to recall this idea of the period of a function, because when we start to be able to graph sine, cosine, and tangent functions, we'll start to graphically manipulate them and need to understand whether or not we're stretching, shrinking, so on and so forth. So this goes back and starts to pull themes from Unit 2 and Unit 3 as we wrap up our journey through pre-calculus. So let's say we have a point here on the unit circle P. Oh, it's not rotating. That's awkward. Put it there. Describe how the x-coordinate of P changes as it rotates once counterclockwise around the circle, and describe how the y-coordinate of P changes as it rotates once counterclockwise around the circle. Think through those coordinate values and what's unfolding. You might want to actually pull out a piece of paper here and write some of them down and look at the behavior that you're witnessing. So, at this point in time, I would definitely want you to pause the video and plot the values of cosine of theta and sine of theta, where theta is the measure of angle in radians. Use two colors. So I'll use blue for cosine. I know that cosine of 2 pi has a value of 1. So I'd plot a point here. And cosine of 0 also has a value of 1. Right. And, obviously we have these 3 points, but we have other points outside of that. So do your best to estimate those values, but you should see a type of repetitive behavior. Use red for sine. I know that sine of 0 is 0. And sine of 2 pi is 0 as well. Right. So I'm going to task you, like I said before, pause the video, make an effort to graph these, because at some point in time, you'll need to be able to graph them on your own accord. And then we have 2 questions here. Why does any angle measure between 0 and 2 pi provide a point on each graph? And do your graphs represent functions? Explain your reasoning. So once again, we're tapping into the multitude of content that we've talked so far, as trigonometry kind of serves as that bridge between the general population who study mathematics and us that pursue more advanced degrees. Hopefully you pause the video, because here, as you can see, are the graphs of cosine and sine. They're obviously not connected. We have the individual data points using all of the values that you are expected to know on the unit circle. Right, if you click the points again, that information goes away. So what do you notice about these 2 graphs, and at what values of theta does cosine of theta equal sine of theta? Where on the unit circle do these points correspond to? Right, so take a look. We should be looking for intersection points. Hint, hint. All right, so here we have the function cosine x plus sine of x. And then we have cosine squared of x. We have sine squared of x. And when we add the squares of those 2 functions, we obtain a horizontal line that goes through the value 1. So I would like for you to write 3 things that you notice, preferably 1 for each of these scenarios. Here we have a graph of sine of theta. Notate the theta axis at the first, second, and last tick mark. So first would be here, second, and last. And then why does the graph cross the x-axis at the 4th tick mark? That's where we're going to pause. If this slide seems like, what the heck was that about? we'll talk about the importance or significance of this and how it pertains to the unit circle. So stay tuned.